S. Chan presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
In part 1 of this lecture, we did bounds of a sequence, and some sequences where we were able to find out convergence of a sequence easily. Now, in this part 2, I'll discuss theorems, where if the sequence nth term is difficult or very complicated, then we can apply the theorems to find or to check the convergence of the sequence. Hello everyone, I am Dr. Seema Thakran. Welcome to S. Chand Academy. For engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. We have two main theorems. One is Cauchy's first theorem on limits, and second is Cauchy's second theorem on limits. I'll state the theorems and I'll take one example based on the theorems. So, Cauchy's first theorem on limits So what exactly the theorem states? The statement is, if an is a sequence such that limit an n tending to infinity is L, it means the sequence is convergent, then limit n tending to infinity a1 plus a2 and so on an by n will be L. It means if you have convergent sequence, then with the help of that convergent sequence, you can find the limit of another sequence which is in this form. And you can see how difficult, complicated this is. It means a1 plus a2 plus an by n. This is the term of the another sequence, and the limit will be limit you will find with the help of the sequence, and the limit you already know. Limit an is L, then limit of a1 first term plus second term plus n the nth term by n, the limit will be same exactly L. So this is the theorem statement. One example if I'll take, you will understand better. So find limit n tending to infinity 1 by n 1 plus, so one example, 1 plus 1 by 2 plus 1 by 3 and so on. Suppose you are asked to find limit of this sequence, and you can see how complicated the nth term is. You cannot find the limit directly, but we have theorem, and how we apply the theorem now. So according to the theorem, n should be in the denominator. You can see very clearly n in the denominator. If it is not, sometimes we divide and multiply also by n. So this is my first term, as if I compare it with the statement of the theorem. So this is my a1, this is my a2, this is my a3 and this is my an. So according to the theorem, if I can find the limit of an, then I can conclude that the limit of this sequence will be same. So now by limit 1 by n tending to infinity. So 1 by infinity is how much? 0. 1 by n is 0, therefore by Cauchy's first theorem on limits, limit n tending to infinity first term. So first term will be when you will put n 1, second term 1 by 2 and so on the nth term, and you will divide it by n. It will 100% be 0, and you can see this is the question which we were asked to find the limit. So we were asked to find the limit of this sequence, and by the help of the first theorem on limits we got the answer. Because the nth term limit is 0, therefore this complete term limit sequence, you can say, this sequence will also converge to 0. So this is our this is the result first theorem on limits. One example also, to understand the theorem. Now, Cauchy's second theorem on limits. Cauchy's second theorem on limits. Now, see the importance of this sequence, this theorem, and the statement goes like limit. If I am writing this directly, if this, it means I have a sequence an and that is converging to L. This is understood by this, writing this only. Now here one more addition. An should be greater than 0 for all n in n. Then limit n tending to infinity a1, a2 till up to an by 1 by n is L. So it means in this theorem, the first thing is an, all the terms should be greater than 0. No term should be equal to 0. And limit an is L, sum L. Then the product of the terms. In first theorem, sum of the terms you were having. Here you have product of the terms. You can see first term, second term and nth term to the power 1 by n. It means this theorem is more applicable in the form where your nth term is in power form. In such questions, this theorem will be very, very helpful. Now, one example I am taking. So, find the limit. The question will be like, and the question is 1 plus 1. So, this is the theorem, and now for the question is if limit n tending to infinity 1 plus 1 by n is E, then this is given, this is not find. If this limit is given to you, then find limit n tending to infinity, and you see the big expression which we are supposed to find out, 2 by 1, then 3 by 2 and so on. The last is n plus n by n to the power 1 by n. This you are supposed to find out. Now, you can compare it with the second theorem, and anyhow big expression, if you don't know the theorem, you cannot calculate the limit. This is given to you only. So, limit an, we can compare, limit an is E. If anyhow, if we apply the second theorem, because an a limit is given, an is what? You can compare, an is 1 plus, so solution, we have an as 1 plus 1 by n whole power n. What will be a1? a1 will be 2 by 1, a2 will be 3 by 2 whole square. What I am doing, I am just putting n1 and then n2 and I am getting my terms. What will be the nth term as per this an formula? The nth term will be n plus 1 by n whole power n. So, I got my terms, and if I just check that here I have product, the expression, the limit which I am supposed to find out, in that expression I have product, and in second theorem only we have the product formula. So, I will apply now. So, by Cauchy's second theorem on limit, my formula says limit product of the terms 2 by 1, 3 by 2 whole square and so on, n plus 1 by n whole power n to the power n will be equal to E, limit n tending to infinity. So, you can see both the theorems helps solving the difficult questions, because otherwise any formula you can apply. Till date there is no other formula except the first theorem and second theorem for difficult questions. So, 2 questions and the theorems also, and one more thing, you can check that all the A1, A2 are greater than 0. That also another condition in second theorem. This should also hold if you are applying the second. For first theorem we don't have any condition, such condition. But if I am applying the second theorem, all the terms should be greater than 0, because we are multiplying. In first theorem we were adding. So, if we are adding 0 plus 1, it is not harming the 0 term, not harming the result. But here we are taking the product a1, a2 till up to an. Any of the term if 0, then it will make the complete expression 0. It means there is no point of applying the Cauchy's second theorem on limits. So, this is the end of part 2, and in part 2 what we did, Cauchy's first theorem on limits and second theorem on limits. Both the theorems help for finding the difficult sequences limits, and if you don't know this concept, you cannot find the limits. So, these are like exceptional theorems, very important theorems if we talk about convergence of a sequence, and very important theorems. So, first theorem was based on if you know the limit of a sequence, then add up the n terms of the sequence, divide by n, you will get the limit. And for the second theorem, if you know the limit and all the terms of the sequence are positive, then you can take the product of n terms up with the power 1 by n, you will get the limit. So, this is all about part 2 of this lecture. For engineering mathematics, please refer to the book by S. Chand Publishing. The book is very good, and you find the concepts very easy explanation for the questions, for the theorems, for the concepts. So please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. Please like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching the upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.